Okay. Great. So fine. Let's try to make the session more and more interactable. I'll have some questions, some basic questions then and there. It will be good if people are making use of the chat option to give the answers. Even if the answers are wrong, it is still fine. You guys can keep posting the answers. That's a way you will learn from your mistakes, right? To get started with, may I know what is the session about, what we are going to discuss today? It's a very interesting topic, and when you are getting into any of the organization, this is the first thing which you are going to use, and throughout your life, you are going to use the one which we are going to discuss today. What is the session about? Anyone? No answers. Let me share my screen as well. Okay. Hope you are able to see my screen. So today we are going to talk about source code control. So source code control is nothing but, let's say if you are getting into an organization, be it a developer role or QA role, data science, artificial intelligence, you will be writing, say, development code using different languages like Java or UI frameworks like Angular, uh, or if you are a QA member, then you will be writing automation scripts, right, which will automatically test the code which are written by the developers. And if you are getting placed in data science or artificial intelligence, again, you need to fine tune your models, whichever you are using, right? So all these code changes should be tracked somewhere, right? So there are multiple tools available to track all the code changes then. And the major ones we are going to look at today, some of the major ones. And we will have a hands-on session as well with one of the tools. Right. This is nothing but whatever code changes you are writing, your team members are writing, we are going to keep them at a centralized place. And why are we doing that? And what are the procedures or what are the flow that we need to take care of? We are going to discuss about all of them today. Now, a simple question to get started with. Why do we need to have source code control in place? It's a very simple question. Can someone answer why we need to have source code control in place? Why can't I keep all the code changes which I'm doing in my local machine itself? Why I need to keep it at some other place? Anybody? There are 5, 6 different colleges here. Techno India, efficient coding practices. Okay. If that's about the second, then yeah, it is coding practices or the source code control itself. Everyone can access code easily. Yes, definitely. Everyone will be able to access the code easily. Any other reasons why we want to have source code control in place? Thanks for the answer, Abhishek. For changes. Okay. So let's assume this use case, right? Whenever we get placed into a company, it is not going to be a one-member team or two-member team. We are going to have multiple team members eventually. It may be 5 members or 10 members, or in fact, you will be working on a very big team wherein it will be having 20 or 15 members team as well, right? So if you are keeping your code changes in your local, the others will not be getting your code changes. That is number one. And even if you are a single member team or two member team, if you are keeping it in your local machine, if something goes wrong, then you will not be able to recover the code back. Right? That is one of the reasons why we want to have the source code control in place. Now, to get started with, software has its own life cycle, and I hope most of you are aware of. We can make changes in language. Okay. Yeah. In other ways, we can take it as upgrades. Upgrades in the coding languages. Yes, that can also be done. And to track all those things, we need to have source code management in place. Yeah. Thanks, JM Jain. And yeah, coming back to the why we need to have. So software has its own life cycle. We generally, it will be discussed in the curriculum itself. So we will have requirement analysis phase. First of all, requirement gathering place and requirements analysis. Then the entire dev and QA teams will go through each and every use cases of those given requirements. Then we will start with development and testing cycle. We'll push the code to production for the end users usage, and post which there will be some say bugs will be coming out, issues, or clients. If you are a client service company, then clients will be coming up with more and more requirements. So to keep track of all those things, this is basically the software life cycle. But to keep track of all these things, we need to have source code management in place. Right? You come up with a new idea for any new feature or enhancements to the existing features, and then your customer come up with new requirements if you are a client service company. And then you find code, you find bugs in your own code, right? It is missed out from multiple layers, it then pushed to production, but then when customers started using it, there will be say minor to major bugs itself, right? And then you want to upgrade the UI or tech stack, as someone pointed out in the chat box. So there will be upgrades keep on happening, right, to the language version, be it language version or upgrading the tech stack itself. So, and then you are planning to go international. Let's say the product which you developed is being serviced in only one country, and later point of time your business is expanding, that your code to be deployed in multiple other countries, and we need to have a localization related changes. Now, to keep track of all these things, it is always better to have all your code, all your source code pushed into a central place wherein people from different locations will be able to access. And all the changes that we were making needs to be managed. So we need to be able to track the changes which we had made, say, be it past 4 years, 5 years, or in fact 10 years. Anytime by anybody, they should be able to go back to a specific date and then check what was pushed on that specific date and by whom. Right? So all those things will help us in making the product more and more stable. And then if there is a chance or if there is a need, we should be able to revert the code as well. It's assumed that we are pushing something to production today, and then when it's being used by customers, they are facing some issues, right? It may be a new feature, or it may be a bug fix which was already found in production. We are making the fix and then pushing it to pushing a new release, and still that is having some more issues, and it may make it even more worse compared to what it was the previous day. So in those scenarios, we will easily take a call to revert back the changes. Right? It is otherwise called as roll back the current version into previous version, because the previous version may be a little more stable or not blocking the customer journey itself, but with the fixes, it is breaking somewhere else and then making it even more worse. So in those cases, we will revert back and then fall back to the previous version. So for all those things, if you are keeping the code in local, it is going to be very difficult. Right? And then distributing change. Eventually, if you are operating from multiple different locations, we have offices in different locations, then distributing the code changes within your team members will be very easy if you're having source code management in place. Now, why do you need to keep track of the changes over time? So this is one of the common things which we will do when we are starting with, right? I will always start with hello world, and then I'll add some more features on top of it. Then I will say my previous code version is hello world underscore world, and my new one is, let's say, underscore one. And then there is a bug. I figure out there's a bug in this file, and then I will add some more fixes on top of that. I will go to 2. I'll make sure these many files are saved just because any newer version, if I'm facing any issue, I will immediately go back to the previous version, right? Let's say from _1, 2, I moved on to 5, 6, 7, 10. So in version 10, when I'm checking some other flow, I'm facing an issue. So I'll eventually go back to 9 and then check the issue still persists. So I'll decide to go back to say version 1 or 2 and then start writing on top of that. So all these things can be kept in local, right? There is no problem of keeping it in local. But why there is a source code management in place? That's what we discussed in the previous slide as well, right? The major problem here is if your system gets corrupted for some reason, you will not be able to recover even a single file of this, right? And then assuming that you are going to work in a team environment, your code changes should always be available to all your team members, because they will be writing their changes on top of your own changes. If you consider all those cases, definitely the option of keeping code changes in local will be ruled out. We should have a centralized place, which is not your own system, but some kind of server wherein you will keep all your code changes, and same with your team members as well. Right? Sharing the changes. So sharing the changes can be done by email, but again, the problem is that stays in your local. There is a problem of losing all the code changes. Yeah. Then there's the other option is we can create a shared folder to save the code. Now again, sharing the code changes by using shared folder, again, it is going to sit in your local machine, one of your local machines, right? Again, the same problem is going to repeat. If your system gets corrupted, then you are going to lose all your code changes. So this is a simple diagram which let us know why do we need to have source code management in place, right? A shared folder or a naming system may work for smaller projects, but then if you are looking at, or you are getting placed in a very big organization, there are multiple projects running. Each and every team has so many team members. So these complex projects, keeping the shared folder or keeping the files in your machine is not going to work out at all, right? That is one of the reasons why we need to have source code management in place. And software projects have multiple files with many changes from many contributors. Let's say if you take up a specific project that may have 500 or 1,000 files, it is highly possible that a 15-member or 20-member team will be touching at least 20 to 30 files in every release. Now, those 20, 30 files may be common to, let's say 4 or 5 files will be common across all developers or all QA engineers. So each and every person will have to touch the same file in the same release. So then there is a problem, right? If you are keeping it in local, at what point of time the person one finishes the code and then gives it to person two. So that is not technically feasible to make it sequential, right? What we need is multiple team members will be able to or should be able to write their code at the same time. So that is nothing but a parallel development, right? So if we consider that, then we cannot keep code changes in local or in shared folder. The other major thing why we need source code management is given by this decision tree. Do you ever make mistakes in your code that you are writing? If yes, then it is always better to have source code control in place. So it is not that everyone will write a bug-free code. Definitely there will be some or the other issues in the code which is written. At what point of time we are figuring out those issues? If you are able to find out those issues before even we go for release, then it is well and good. We can make the changes and then go for a release. But most of the issues will be visible only when large number of users started using the application, which means it is already live in production. So I should be able to go back and refer my code and figure out where is the exact issue. Then I need to write the fix, deploy to production once again. So which means the issues can open up anytime. So definitely everyone will make mistakes in their code, and it is always better to have source code management. Let's say there is a guy who's very well versed with writing codes, and he or she doesn't make any mistakes in their code written. Is your colleagues going to make mistakes? You can give surety that you by yourself will not make any mistakes, but the team member who's part of your team, they can make mistakes, right? Now to go back and check what's the mistake that they had made, the code should be available, available to everyone and somewhere at the centralized place, right? So these are the reasons. Again, if you are giving confirmation that you are not making mistakes and your colleagues are also not making mistakes, then there is something seriously wrong which we will have to fix. right? Definitely there are softwares which are having so many issues. So that being said, to check back the code, what is the issue that we are facing and where is the issue, fix them and then push it to production. That is one of the reasons. And second, shared folders or keeping the files projects in local will work for small class projects, but not for organization level or very big projects. And it has multiple files and many changes from multiple contributors at the same time. Now that is not feasible with sequential development, and we need to have parallel development enabled. For that, your code should be available in a centralized place. So these are some of the common reasons and common use cases why we need to have source code management in place. So let me take a pause. Any questions so far? If you have any questions anytime, please keep posting them in the chat box. Now, moving on, why we need to have source code control system, or what are some of the common terminologies or use cases which the team is getting by using source code management, source code control in place, right? It allows users to keep a record of file version. So let's say in current release, you are making a feature, you are using a file, and in the next release, you are going to enhance the same feature which is written, or maybe 6 months down the line, 1 year down the line, you are going to make improvements to your own system. Say, for example, we use WhatsApp day in and day out. How frequently WhatsApp gives releases? Can someone take a guess? How often WhatsApp makes app releases? We use WhatsApp almost every day, every hour, or Facebook, Instagram for that matter. How often do they make releases or changes? Can put the answers in the chat box. The question is, how often WhatsApp or Facebook, Instagram makes a new release to the applications what we use? 25 days, okay. Any other answers, guesses? Eventually from your mobile application, you will be able to go to App Store or Play Store based on which OS version you are using. You will be able to check how often they are making a release. So Facebook, for that matter, had a policy of every 15 days release. So every 2 weeks, there is a new app version available. And since we have auto update, most of us have auto update enabled in your phones, we will not even notice that there is a new version released. And same with WhatsApp. Even if it is not 15 days, again, less than a month, they are going to give a release. Now, just imagine if you are doing 4 years course or maybe 5 years course, by the time you start your university course and then graduating, there are nearly 40 to 50 releases happened just from WhatsApp or Facebook or from Instagram. So 40 to 50 releases. Now just imagine for 40 to 50 releases, how many code changes that you are going to make in the same file, same feature file, and you need to keep track of all of them, right? That's a major use case why we need to have source code management in place. So any day, if you ask me that what was it before 2 years, or what was it when the feature was introduced, I should be able to go back and check the code and figure out what could have been done better. All those things should be, the team should be enabled to do all those things by using source code management. So let's go through some of the common terminologies which is being used at the organization level, right? Backup and restore by using source code management. So backup is nothing but we know, right? If something goes wrong in your machine, you should be able to get the last ever known code. That is nothing but you are pushing your code changes to the server, and restore is you are getting the code changes from the server from a specific point, right? Let's say even if my system is not getting corrupted, I'm working on a specific feature, and my manager or my head is saying, okay, there is a issue reported by the customer in the last released version. You may have to go and check what is the issue. Then eventually I will try to restore my code or switch to a different release version and check what was the code written and what is the issue, right? So source code management enables us to take a backup of all our code changes and then restore whenever it is needed. And then synchronization, which is nothing but, let's say I'm working on a team which has somewhere around 10, 15 members. I need to collaborate with all others and get the changes in real time. Let's say I'm depending on somebody else's code. I need to have his or her code so that I'll make my changes on top of that. Right? So that is possible by using source code management, and the terminology is synchronization. So the other person will be pushing the code to server, and from there I'll be taking a copy of it. Right? We will see how to push it and how taking the copy will work in the hands-on session. But just keep these terminologies in mind; it will be helpful. And then redo, undo. We usually make mistakes, and then we will have to go back to the previous version, completely get rid of the code which was written, and it should be done, be it short term or long term. Let's say I'm developing a feature which is a very big initiative for 5 months, 6 months, and for some reason it is not working out or it is not getting good traction from the customers. So we can abandon the complete feature altogether and go back to the code which was used 6 months back. Right? Or any small mistakes, we can simply get rid of the code and then start from where it was pretty much stable. And to do all those, it is better to have code in the centralized place. And then track the changes. Since we are all working in a group, or we are going to work as a we always wanted to know who made the code changes and explain why the change was made. We need to have, we should be able to track all those changes, right? So that is always better, and the person should be able to explain, or even the person should be having the code first to explain, right? We will develop a feature right now and move on to something else, and we'll have to come back and check what was the previous feature and why the code was written. So all those changes can be tracked by using source code management. And then eventually, since it is going to track who made the code changes, it tracks the ownership as well. So if a person who's writing the code, the source code management will be used to even give credits or to blame. Right? If something goes terribly wrong, we will go and check who made the code changes, and the person in charge will be able to should be able to answer. Or if a feature which made very good impact and it is very much optimized and it runs in a real good time complexity, then we will be able to track who made those changes, and we should be able to give credits as well. And the branching and merging, we will look at it in detail in the upcoming or in the hands-on session. Say branching is nothing but I will have one centralized code, and in a given release, we will be working on 2 or 3 different features, right? So from the central code, I will create 2 or 3 different branches, and each and every feature development will be happening in a specific branch. And from there, the merging happens to a common release branch, right? Let's assume that release is the branch we are going to push all our code into production. So we will create a release branch from the previous version first, and the new feature development will be happening from the new branches created from release. And once the development is done, testing is completed, we will be merging everything into a release branch. From there, it will go to production. So these are some of the common terminologies and the very evident use cases of having source code management in place. So let's take a minute to go through all these terminologies, which will be definitely needed and useful in the long run. Meantime, if you have any questions, please keep posting it in the chat box. Okay, moving on. And some of you might be already using one or multiple of these source code management tools. May I know if anyone is using one of them already, and if yes, what is the tool that you are using? Is it GitHub, GitLab, Bitbucket, or Visual Studio, or Subversion? Which tool that you are using? It may be for your college projects, or you had done an internship in any of the companies, and what is the tool that they were using? The terminologies which we see in the previous slide is common across all these platforms, like branching, merging, GitHub. Okay. Puneet had used or using GitHub, which is good. So different companies use different tools for certain reasons, but these are some of the very commonly used GitHub, right? Krishnan Rangaswamy is using GitHub. So these are very commonly used tools, and it is well and good that if you are learning one specific tool and you can easily extend your knowledge to any other tool if you're getting into an organization, right? So today we will look more into GitHub that is being used by most of the folks. If you are knowing GitHub really well, then GitLab and Bitbucket are going to be very easy. And same with Visual Studio, source code management, or some versions. So these are some of the commonly used tools. So this is very important slide where it talks about what's the difference between these items itself, right? GitHub, GitLab, and Bitbucket falls into one specific group, and Subversion falls into a different group, which is nothing but single versus distributed, or centralized versus distributed. So single server or centralized is nothing but there will be one central server where user has to commit all their changes. By any chance, if the central server goes down, you will not be able to access the files, which is very straightforward and very easy to understand. If the central server goes down, we will not be able to access the files. But regardless, it is sitting in a centralized place. It is sitting in the server. It is not sitting in your local machine at all. And if the server is corrupted for some reason, you will lose all the history. There is no way to recover back. For example, Subversion and CVS are using centralized system or single server system. They will not have a copy of it anywhere else. On the other hand, distributed is it clones a copy in your local machine, and the distributed itself will be keeping a copy in multiple places. So user can commit the code changes offline in your own machine, and then whenever you come online, it will be pushed to the server. We will see it in the hands-on session how this works. And if central server is corrupted, there are multiple ways to recover your code copy. First of all, you will be having a copy in your local, and the distributed server itself will be keeping the code in multiple places. So even if the distributed server, one of the server gets corrupted, you will be able to recover copies from different places. The examples are GitHub, GitLab, and Atlassian Bitbucket. Right. That being said, I hope it is very easy to understand the centralized or single server versus distributed server. Which one seems to be more advantageous? Is it centralized or distributed? If you want to choose, which one you will choose? Leave about whether we are going to use GitHub, GitLab, or Bitbucket. You can say, I want to go with either distributed or single server. Which one you want to go with? Distributed. Yeah, Darshini says distributed. Sneha, distributed. Okay. Yeah, okay. So very clearly, distributed seems to have more advantages compared to centralized, right? Distributed. Krishnan, yeah, thanks. So I have a very simple question. If everyone want to go with distributed, why even the centralized server concept is still existing? Because as I said in the previous slide, different companies use different source code management tools, right? There are still more number of companies still using Subversion. But if we see Subversion is nothing but a centralized server or a single server concept. Why a company even wanted to go with centralized? What may be the use case of going with a centralized server? Just think about it. If everyone is choosing distributed, definitely single server should not even be existing, right? But it is still there. Still companies using CVS, Subversion, all those things. Why? Why? What might be the reason? Any guesses why still single servers are existing or the centralized system? Security, yes, it's correctly pointed out. Security, what type of security? So definitely security is the answer. There should be some kind of security measures which single server or centralized system possess, which is not there with distributed systems. Source code security, okay. Any industry which needs source code security? Because if we see distributed, we can in fact secure our source code. You can make it private to your organization, wherein if you are logging in apart from your company email address, you will not be able to access the code, which means source code is still secure. It is private to your organization itself. Authentication, okay, authentication security. Any industry which needs source code security itself, wherein the code shouldn't be accessible outside. Thanks, I'm getting good answers. Thank you. So basically, banking domains. If you get a chance to work on any, yeah, exactly, on it, banking. So if you get placed in any of the banking companies, right, or the development of banking software, the code will not be or should not be able to accessible outside. So you get into the company, you will log into the system, write your code, and you will not be able to get the code copy outside of the system itself, right? So you will be logging into the centralized system, write your code, push your code changes, that's it, you are done. The point which is mentioned here, user can or user clones copy of the repository on their workstation. That will not happen with centralized server at all. Financial service providers, yes, that is right. So anything which is related to finance banking, they will always use Subversion or CVS. It is very highly unlikely to see any banking company using distributed servers. They will always go with Subversion or CVS because the code shouldn't be able to accessible outside. So that's why both the systems are very much still existing in the market. And based on your use case, your team is or your company organization is going to choose which source code management platform we want to use. Right. Moving on. Again, this slide we will go in detail in the hands-on session. These are very commonly used terminologies in day-to-day life if you are getting into a company. Right? A repository is nothing but the place where all your files or your entire project is stored. We are going to look at the repository itself. How does it look like and how can you view your files? So all those things. So repository, you just assume it like that's a code or your complete project pushed into the centralized server, right? So that is nothing but repository. Clone or checkout is nothing but downloading a copy of the project into your local machine. So you will be able to clone or check out the complete repository itself. Clone is nothing but for the first time you are, I cannot say it is a download because download is offline download as well. Clone is nothing but for the first time you are trying to get the code from the server. Checkout is nothing but from there on, a specific branch you want to merge or you want to move into, that is called checkout, right? Clone and checkout. Working copy is nothing but your local copy of files. So we will have a copy of the file or the project in your local machine. That is called your working copy. Pull request or change list. So this is where rest of the teams comes into picture. Right? Until now, it is all to yourself. So you have a repository, you are cloning or checking out a copy of the code. And in your working copy, you are making all your code changes. And submit or push commit, you are going to make the code changes and you are going to commit them. But pull request is something which is very important, wherein you are going to let your team know that, hey, I made these changes in my specific branch. Now I want to merge this branch into the release branch so that my code changes will be deployed to production. Now that merging will not happen on your own, right? your higher levels, say you are getting placed into a company, you will have a team lead, team manager, or even much more levels, right? So your code changes will be reviewed by multiple people, multiple levels of people. So that will be initiated by using the pull requests, right? Your code changes to go into a release branch. There is a pull request created, and the review will be done by multiple members in the team. And even if you're getting placed now, you will be able to review your senior's code as well. So pull request is something you will be able to view it clearly in the repository itself, which I'll show in the hands-on session how the pull requests will work. Right? And then submit, push, check-in is nothing but you have the changes in your local, and then you are committing all the changes. And after committing all the changes, you are going to create a pull request. And if the pull request is approved, your code changes will be merged into the release branch. And from the release branch, the release manager will be able to push the code changes to production. Update or sync is nothing but, let's say you are done with all your code changes and your team members are also done with their code changes. At some point in time, you need to have the latest code, right? So update is nothing but from repository for that specific branch, you are saying, give me all the changes, which is also called as pull. Pull, update, sync, all of them are with same meaning. They are used interchangeably. So revision is nothing but, let's say you wrote some piece of code. Unfortunately, it had some issues. So you want to go back to a previous version of the code. So revision is nothing but a unique value with which you will be able to go to a specific version of the file. So that is called as revision. So these terminologies are very, very common in your day-to-day life if you are working in an organization. Right? Let's take a moment, go through all these terminologies. Just keep them in mind. We are going to look at all of them in detail in the upcoming hands-on session. And any questions on these terminologies, please let me know. Please keep posting it in the chat box. Okay, I assume there are no questions. Moving on. So as we discussed before, creating a GitHub. So GitHub, some of you are already using GitHub, and you can go ahead and create a new account. It is for free. You can create an account in github.com, and you will be able to select 2 to 5 users for your project. It is, I think, till 5 users or so, it is free. If you are using, or if you are including more users into your repository, then you need to have a paid account. And you can always look for Git help, which will give you all possible commands which you can use with Git. Right? You will also see this Git help and see what are the commands it is giving in the session. Okay, so in general, this is the complete flow. Yeah, before covering the left-hand side, let me cover the right-hand side first. Creating a new repository. So Rahul is nothing but the username, the user who has the account. And this is how the new branch will be created. So this test rep 1 is a new repository, not a new branch, but new repository. And it will have either public or private access. So if you want to have more and more private projects, then you will have to have a paid account. But public repositories are free of cost. We can create public repository, and after creating this public repository, that is sitting in this remote repository, GitHub Cloud or GitHub remote repository. And from there, you do a local checkout. In the previous slide, we had seen checkout or clone. You will clone the repository in your local. So this is your local machine, and the repository is sitting in your local. And you have a working copy. So from working copy, stage is nothing but your commit. Once you are done with all your code changes, you will do the commit, which is nothing but staging your changes. And from there, you will push it, which is still sitting in your local. You create a pull request, and once the code is merged, that is synced with the release branch in the remote repository. That's how the flow happens. We will try to see as much details as possible in the hands-on session, but this is the common flow. It's a very simple and a straightforward flow, how it works from the remote repository to your local and from to your local to remote repository. What are the steps involved? So these are the 3 or 4 different steps involved in pushing your code changes or pulling others' code changes. Okay, so as we discussed, git clone is nothing but checking out or cloning remote repository into your local. You need to give a path till your project name. You can work on your local copy and then push back your changes to the remote whenever you need. So for that, the command is git push, and you need to mention the branch name. So git clone, checkout, git push. These are some of the common commands that we are going to use. So we will use as much commands as possible in the hands-on session, but git clone, git help, git push, checkout, these are some of the very common commands. Okay, any questions so far? We are almost done with the theoretical session. We will start with hands-on, but before that, you guys have any questions, please keep posting it in the chat. We'll give a minute or two to have any questions answered. Okay, so can we use GitHub while working on open source? Okay, so this comes with 2 different parts, right? We can definitely use GitHub while working on open source, because open source is nothing but you will be able to take the code, make your own code changes, and then push it to wherever you want. But again, if it is related to a specific organization, you need to check with your organization whether you are allowed to use GitHub private account or your own personal account to push the code changes of the open source code, right? Or if it is your own project, let's say your college project or your own internship project, then you are feel free to push it to GitHub. But if it is related to organization, it's better to check the organization rules and rules, that whether we are allowed to push the code changes to private GitHub account. Okay, we will take a short break and we will group back by 3 p.m., 10 minutes break. 3 p.m. we'll start with hands-on. So a request is, if anyone has or whoever has the laptop, please come with your laptop. And if possible, create a GitHub account and keep it ready. What we are going to do is we are going to create a new repository and check out the repository in your local, make minimal code changes or as simple as adding 2 numbers, and then push it to the remote repository and create a PR, pull request, how it is going to look like, the complete flow we are going to look at. So whoever has the laptop, please create a GitHub account and keep it ready. Or we are anyway recording the session. Post the session, the recording will also be shared. You can use that and do a hands-on little later. Yeah, thank you. We'll connect back at 3 p.m. Okay, so it is 3 p.m. We'll give a minute or two and then get started. So meantime, whoever is on the call, can you guys tell me what are the common terminologies that we use with source code management? Common terminologies. Version control, okay. Commit, okay. Any other common terminologies? Repositories and branching, fine. Nice, okay. Let's get started. Yeah, clone, yes. Good answers. Pull request, yeah. Branch, fine. Wait, I'm sharing my screen. If you guys had a chance to create merge, yes. If you guys had a chance, please give me a thumbs up if you're able to see my screen. Yeah, okay, thanks. So if you had a chance to create a GitHub account, this is how it is going to look like. So there will be a overview tab wherein it gives you, okay, it gives you what are the popular repositories you have. These are the popular ones, not all the repositories. All repositories you will be able to find out in the second tab. And these are your popular repositories and your personal profile. What is your contribution in the past 1 year? And throughout the years, you will be able to see your contribution. And the very recent activities will be listed in the bottom section. And you can get into any of the repository to check the project structure. And this one specifically is a mobile application. So I have this Xcode project. Xcode is nothing but it's a tool used for iOS application development. And we have multiple other tools like IntelliJ and VS Code for different use cases, right? And if I go into Omnify, I will be able to see my files as well, right? This is mobile specific. And since I'm inside a specific project, I'll be able to see issues, pull requests, actions taken, and all other settings, right? And this pull request place is where we will see if there is a pull request open. We will create a repository, new repository, clone it in your local, and make code changes, push them to your repository, and then create a pull request. We'll see all those things. Yeah. And this is your profile, which has much more options. So I'll say my repositories. I have somewhere around six repositories. Yeah, 6 different repositories. Let me create a new one. And as we seen in the presentation, the owner of the repository is Ashok Kumar, and repository name is nothing but what we want to create. It's nothing but a project. And description is optional. And whether I want to make this repository public, available to everyone, or private. within my community. And if I need, I can add a README file. So it is highly appreciated that everyone should have a README file wherein you will give very common or get started guidelines itself, right? When you go into let me see if I can show something. Okay, yeah. So if I go into any of the open source platforms or even paid libraries, we will see how to use them, right? So this is a browser use tool where we want to set up how we want to set up by using pip install, browser use, playwright install. So these are the commands given, right? This is kind of get started guide, and all these will be put up in the README file. If you can see at the top left, it says README. So if you are going to open up your software to anyone else, you need to have README updated to whatever extent possible. It is going. It should show all the information of how to use your application. So that's the use of README file, right? And let me create a README file. Create. Sorry, repository name. I will name it as session March. Today is 7/07. So this is going to be my repository name. I will create a repository. Now the repository is created with only one file, which is nothing but a README file. Yeah, and right now my repository has only one branch, which is nothing but a main branch. That's a default branch as well. And I can create multiple branches, which we will see how to create. And we will not create branches from GitHub console itself. Instead, we will create branches from my IDE. So IDE is nothing but my integrated development environment, where I'll clone the copy and do my development. So I'll have to stop the screen share to open up my IDE. IntelliJ is the IDE which I use for backend development, which is Java development. And we will use the same here. Okay. So when I open up IntelliJ, I can create a new project with the same name. So basically, when you get into a company, all these things would have been created already. So you can simply do a checkout of the branch. But since we are getting started here, I'm just taking you through all the steps. So March 7th, March 7 is the repository name. And if I go in, sorry, let me try to share my entire window so that I don't need to stop. I don't need to share them again and again. Okay, I go into IntelliJ and downloads. Let's say if I go into the repository which is created, we will see only the source folder and IML file. This is support file, you can safely ignore. And there is something called idea folder. There is nothing called git to push it, right? So what I have to do is I need to create a git folder. You can use the terminal window. You say git, which is already in, if you can see, this is already in session March 07 folder. If it is not, then you will have to navigate to the folder and then say git init. Now this does something, right? It does something. If you go back to the folder now it has git. So it had put up something. which means I am able to connect the specific project with the repository that I created here. So now these two are linked. I should be able to push all my code changes. Yeah. Now, what I will do is, this is the only file available. I'll create a new file. Or let's try to push this file itself. Yeah. I'll say git status. Status is nothing but this is going to show me which are the files which are not added to the commit. So these two folders, which is the idea folder and the IML file, these two are existing in our local, but it is not added for any of the commits. What it says is use git add and the file name to include in what will be committed. I can either say git add session March 07 IML, and again I need to say dot idea slash. Instead of doing it file by file, what I will do is I will say git add space dot. What it does is it will add all available files for the commit. Now if I say git status, it has all these things added. What it does is it automatically went inside idea folder and then started adding file by file. Just with one command, I said git add dot. It added all the files which are inside the folder and the file which is outside as well. Now everything is ready to commit. This is a terminal where I'm working with. On the other hand, there is something called commit on the left-hand side. If you can see here, you can go into the commit and expand. It still shows the same 7 files, right? Whatever is there inside, Kotlin Java runtime, miscellaneous XML file, modules XML file, run configuration XML, all these things are in fact here. They are already added for the commit. But there is one file, if you can see, git ignore, that is with striked out symbol, which will not be pushed. Because when we were creating the repository, what we did was we asked this repository to ignore git ignore files. So that is not needed to be included. Yeah. So we'll go back to the project. Now these files are added for commit. Now we will do commit. That is the next term, right? Git status is one term which gives us what are the files which are ready to be included, but then it is not included. You say git add dot, which will add all the files which are not added yet, all of them. Now I'll say, or we'll go through git help. That's what we had seen in the previous the presentation, right? If you go through git help, it gives multiple commands. Clone, which clone a repository into a new directory. Init creates an empty git repository. Init is what we used before, right? And then add file contains to the index, and then mv restore. So there are multiple commands. We can go through each and every command. And commit is the one we are going to look at it now. Record changes to the repository. Now the syntax is git commit. If I want to give, if I say git commit, it is going to push all the files which are already added. But I want to give some message. I will say message to be given. And my first commit. Say my first commit. What it says, git commit my first commit. It says master is the branch, and my first commit, 7 files are changed. 60 plus insertions, 60 you can leave it. It includes the line numbers as well. There are 7 files totally pushed. So these are the 7 files which are pushed. Now, if I go and refresh it here, the files are still not reflecting. And this is main branch. Master branch is also not reflecting. Here it shows master branch. Master is not reflecting here. And none of the files are coming up. What might be the reason? We did a commit and the commit is also successful. These are the 7 files which are committed. Why is it not reflecting in my remote repository? What might be the reason? Any idea? I'll stop and reshare because it creates a chain effect. But what might be the reason why the files are not reflecting in the remote repository? Anyone? Any guesses? The reason is we just committed the changes. So committing the changes will stay only in your local. It will not go to the remote repository. To go to the remote repository, what is the command that I will have to use? We saw in the presentation as well. Any idea which command we will have to use? No. So it is git push. So git push is the command that we need to use so that the file changes will be pushed to the remote repository. If you can see, git push to the origin called master. Okay, so it says the repository is not found. I think there is a mistake with the name as well. Sorry. Okay. Remote origin. So this was my previous. So this connects the origin versus the current one. Session underscore March score 07 dot kit already exists. If I push it to okay, I'm facing some problem with the access rights. Maybe we'll create a new repository and do the same operation again. But this is what git push will help us to push all the code changes to the master. So let me create a new repository, which I'll say March 2. Underscore 072. So if you don't add README file, it will ask us to add README file. And what are the things we will have to do to connect the remote repository with your local. So even here, what we will do is we'll create a new project. So it doesn't have commit or git. So the first step I'm going to introduce is git init. Then I will check for the status, git status. These files are not there. So I will add them. Git commit. I'll say my first commit. So it is all committed. It says I need to do remote add origin setup. So this basically connects the two, and then I will push it to main. I will check what is the branch here. The branch here is master. Okay, now if you can see, the moment when I said git push master, writing the objects, there are 10 objects to be pushed. It is all pushed. A new branch called master is created in my origin. Origin is nothing but my remote repository. So now if I go and refresh it here, I am able to see idea and the IML files available, and the branch name is master. Yeah. So any questions so far? Creating a repository, linking them, and pushing your initial commit. And if you can see, the commit message is my first commit in both of them. Any questions? We will see how to create a new branch, make the code changes, follow the same, push it to the remote repository, and create a PR to master. That's our next step. PR is nothing but a pull request. I'll quickly check if there are any questions. There is nothing yet. So I'll give a minute to see if there are any questions. Okay, there is none. Let me share my screen again. Now what we will do is, we'll say git status. This says that I'm in branch called master, but master is considered to be a stable branch, right? We are not supposed to write code or create pull request to the master directly. So what we can do is we'll create a new branch called release branch, and add a sample file, and then create a pull request from release branch to master. That's our next step. To create a new branch, git can use git checkout if you, and then the branch name. Let's say release. It says the syntax is wrong. Okay, let me say git help, which should create or delete branches. So git branch, it is in master diagram. Okay, let's say we'll search for create git create branch command. It says git checkout. Okay, branch name release already exists. We are still in master. So git checkout branch underscore one. Yeah. So minus B is the command to create a new branch. Git checkout branch release underscore one. Now, if you can see, switch to a new branch called release one. If we say git status, it says we are on release one branch. Yeah. What we will do is we will create a new Java file, Java class, and I will say get started. Now there's a new file called, okay, it says whether you want to add file to the Git directly. I'll say add, and then public static void main. I'll simply say sys out. And just say 5 plus 2. Or for that matter, we'll simply say hello world itself. Now, if we say git status, it says get started.java is the new file, and that has code changes in your local new file, and then it is modified. Again, the same steps we need to follow. Git add dot, which will add both the files for committing. If we again say git status, now these two files are already available, and then I will say git commit messages hello world file added. Now these are committed. The changes are committed. If you go back and check here, it is not pushed yet. We just did a commit. We didn't push it yet. So let us push it. Git push origin. Now instead of master, it has to be release underscore one. Okay, now it is pushed to release underscore one. We'll go back to the repo, and it automatically gives, right? Release one has recent pushed 2 seconds ago. And it also says compare and create a pull request. Yeah. So now if we refresh, release one should be available. Let me refresh. If you can see, there are two different branches, master and release one. And if I want to create a pull request, it automatically pre-fills the commit message, right? And the pull request, if you see the top section, the pull request goes from release one branch into master branch. And it is able to merge. There are no issues found. It can be automatically merged. But in the real world scenario, you will always have reviewers. Now there are no reviewers here. If I tap onto the reviewers, you can add up to 15 reviewers to this pull request. I will say no. So the collaborator should be added to this project. We will come to collaborators, and the hello world file added. I can say print hello world segment. Data pull request. Now that's all. We had created pull request. If you go back to code on the top left corner, in the master branch, there are no Java files. And if you go into release one, there is a source folder added, and inside source folder I have a Java file, and only from the master release can go. So what I did was I created a release one branch, made my code changes, and created a pull request, which you can see it in the open pull requests. If you go into this specific pull request or hover over it, it shows me from release one, it goes to master. Yeah. And if I go into commit, it tells me there is only one commit. And that commit is nothing but I added a class and a method. In that method, I'm saying hello world. As a reviewer, if you want to add any comments for a specific line, you just say can add two numbers here. Okay, so this is still pending with the owner. So this comment is added right now. And if there are multiple files, you can review all those files. And wherever you feel like there is a change required, you can start adding the comments. And the owner of this pull request will go through all the comments, address them, and then update this pull request. That's how it works. And finish your review. This will push me submit review. So this will push a message to the owner of this pull request. So until these comments are resolved and completed, I will not be approving this PR. Without approval, it cannot be merged. So here we don't have any rule set up. If there are rules, as in if there are reviewers to this pull request, if the reviewers are not approved, this pull request will still remain open, will not be able to merge. And the files changed in the specific pull request are two files. BCS XML file which got added, and get started.java got added, and there is a comment added to this as well. It's assumed that everything is clear, and your respective team lead will merge the pull request if there are no more changes required, right? So here is the merge pull request option, and merge the pull request from release one into master. I'll say confirm. And before, if we see, master didn't had the Java file. Now I'm in the master branch, which has the source folder. And if I get into the source folder, I'm seeing this get started.java file as well. So this is how the merging happens from a different branch into master branch. So as we discussed before, let's assume there are 3 different developers. All of them will be having their own branches. The release branch name is not proper. Let's say you will have, basically we will have the developer name / the feature name. So in my case, I will say Ashok Kumar / get started or hello world. That will be my branch name. From there, if I'm done with my development, I will create a pull request to master. So my respective lead will review all the code changes, approve the PR, and merge the PR into master. So that's how master gets the updated copy of all the code. Now developer 2 will have to pull the changes from master. That has my changes already merged. Yeah. So every morning, it is advised to pull the changes from master, so that you have the code copy of what your colleagues had written in the previous day. Right. I'll stop here and I will pause here for any questions. You're pretty much done with the common commands which are being used. Deleting the repository and any other complex stuff we don't need to go through right now. But creating a repository, checking out the code copy in your local, committing the code changes, pushing the code changes to remote repository, create a pull request, and merging the pull request into the master or release branch. We have gone through these steps, and these are done in day-to-day activities in any of the developer's life. Yeah, developer or tech team's life. So I'll stop sharing. We'll look out for any questions if any of you have. or if any of the steps are not clear, we can revisit them again. Okay, I assume there are no questions. So we'll stop here. We had gone through all the common commands, and there will be a follow-up assessment, which will be shared with all of you. And any doubts, you can reach out to the same WhatsApp group. I'll be able to respond back anytime. Yeah, thank you, and all the best, everyone.